What if Tesla's next Roadster isn't just an electric supercar? What if part of its performance technology comes from SpaceX? For years, Tesla has promised a Roadster unlike anything else on the road. Tesla's current Roadster page lists a claimed 0 to 60 time of just 1.9 seconds, a top speed above 250 miles per hour, and up to 620 miles of range. But now, a far more unusual possibility is making headlines. Reports say Tesla may demonstrate a limited edition Roadster using cold gas thrusters developed with SpaceX. If that happens, this wouldn't simply be another fast electric car. It could be one of the strangest performance experiments ever attempted by a major automaker. But there's a much bigger question. Is this really the future of the Roadster, or a technology demonstration that may never become a production feature? That's where the story gets interesting. The Roadster has always been more than just another Tesla. The original Roadster helped establish Tesla as a serious electric car company. Now, nearly 2 decades later, the next generation Roadster is supposed to play a very different role. Tesla isn't simply trying to build another electric sports car. It's trying to redefine what an electric performance car can do. Tesla's official specifications already describe an extraordinary target: 1.9 seconds from 0 to 60 miles per hour, a top speed above 250 miles per hour, and a claimed 620-mile range. Those numbers alone would make the Roadster remarkable. But SpaceX technology takes the idea into another category entirely. And that's where we need to separate what Tesla has actually confirmed from what is being reported. The most important phrase here is cold gas thruster. That does not mean Tesla is putting a conventional rocket engine inside a production Roadster. And that's an important distinction. According to recent reporting, the proposed system would use cold gas thrusters developed with SpaceX for a demonstration vehicle. Reuters reported that a limited edition Roadster demonstration could take place at SpaceX's McGregor, Texas test site. Tesla had not responded to Reuters' request for comment at the time of publication. So what exactly is being discussed? The concept is essentially to use compressed gas to create short bursts of thrust. That is fundamentally different from a combustion rocket engine. There is no need to imagine a Falcon 9 engine sitting behind the driver. The idea is much more specialized. A compact propulsion system could potentially generate additional force for specific performance maneuvers. And that raises an obvious question. Why would Tesla need it on a car that is already extremely fast? Because acceleration is only one part of performance. Imagine a car that already has enormous electric motor power. Adding more conventional motor power eventually creates diminishing returns. Traction becomes a problem. Tires become a problem. Weight becomes a problem. And physics becomes the ultimate limit. A separate thrust system could potentially provide force without relying entirely on tire-to-road traction. That's the fascinating part. But there is an important limitation. More thrust doesn't automatically mean better handling. A car needs to remain stable. It needs predictable control. It needs to stop. And it needs to operate safely. So the real engineering challenge isn't simply, can you make the car produce thrust? It's, can you control the thrust precisely enough to make the car better? That's a much harder problem. Before getting carried away with the SpaceX story, it's worth looking at the Roadster Tesla has actually presented. Tesla describes the Roadster as an all-electric supercar designed around performance and aerodynamic efficiency. The company currently lists a 1.9 second 0 to 60 time, a top speed above 250 miles per hour, and a 620-mile range on its US Roadster page. Those are already ambitious targets. And the Roadster is supposed to seat 4 people while offering a removable glass roof. That combination is unusual. Most performance cars force buyers to choose between extreme performance and everyday practicality. Tesla has positioned the Roadster as something different. A car that could combine supercar performance with electric efficiency and everyday usability. The SpaceX concept would push that philosophy even further. This may be the most important part of the entire story. A demonstration vehicle is not necessarily a production vehicle. Recent reporting suggests the proposed thruster-equipped Roadster could be a limited edition demonstration vehicle and may not be intended as a conventional street-legal production car. That distinction changes everything. A technology demonstrator can be built around a very specific objective. It doesn't necessarily need to satisfy every requirement of a normal consumer vehicle. A production car is different. It needs repeatable manufacturing, safety validation, regulatory compliance, reliability, serviceability, and a practical ownership experience. That's why the biggest question isn't whether Tesla can demonstrate the technology. It's whether Tesla can turn that technology into something practical. Let's imagine the system works as intended. A thrust system could potentially provide short bursts of additional force. That could theoretically help with acceleration or other performance maneuvers. But without detailed official specifications, we shouldn't pretend to know exactly what the final system will accomplish. We don't have enough confirmed public information to say precisely how much thrust it would produce, how long the system could operate, how much compressed gas it would carry, how much weight the system would add, or exactly how Tesla would integrate it into a production vehicle. Those are critical engineering details. And until Tesla officially publishes them, any exact performance claims should be treated cautiously. This is where EV Insider takes a different approach. We're interested not just in the spectacular claim. We're interested in whether the engineering makes sense. Every new system adds complexity. A thruster system needs hardware. That hardware needs mounting points. It needs controls. It needs storage. It needs safety systems. And all of that adds mass and engineering complexity. For an ordinary vehicle, that's already a major concern. For a performance car, it's even more important. Because the Roadster's entire purpose is performance. If the system makes the vehicle significantly heavier or harder to maintain, the benefits could be reduced. So Tesla would have to find the right balance. More thrust versus more complexity. More performance versus more weight. Extreme technology versus practical engineering. That's the real battle. So why involve SpaceX at all? Because SpaceX has years of experience developing propulsion systems, pressure systems, flight hardware, control systems, and high-performance engineering. Tesla and SpaceX are separate companies, but they share a common connection through Elon Musk. And the idea of transferring engineering concepts between them isn't entirely surprising. The interesting question is whether technology originally developed for aerospace can provide a meaningful advantage on the road. A rocket operates in an environment where weight, thrust, pressure, and control are everything. A car operates in a completely different environment. It has pedestrians, other vehicles, road regulations, tires, brakes, passengers, and public safety requirements. So transferring technology from a rocket company to an automobile is not as simple as copying a component. It requires redesigning the entire system around the vehicle. And this brings us to the biggest issue: safety. A system designed to produce additional thrust introduces a completely different kind of engineering challenge. What happens if the system fails? What happens if thrust activates unexpectedly? What happens during a collision? What happens during maintenance? And what happens if the vehicle is operating near other people? These aren't minor questions. They're exactly the kinds of issues that would need to be addressed before any unusual propulsion technology could become a normal consumer feature. That's why a controlled demonstration and a production vehicle are two very different things. So why pursue something this complicated? One possibility is differentiation. The performance car market is already crowded. Electric cars can accelerate extremely quickly. Companies around the world are producing increasingly powerful EVs. Tesla needs something that makes the Roadster unmistakably different. A conventional electric supercar competes on speed. A Tesla Roadster with SpaceX-inspired technology could compete on something much harder to copy: engineering spectacle. It could turn the Roadster into a technological showcase for the entire Tesla brand. Not necessarily a mass-market product, but a demonstration of what Tesla believes is possible. From a business perspective, the Roadster doesn't need to become Tesla's biggest-selling vehicle. That's not its role. Model 3 and Model Y are designed for much larger markets. The Roadster is different. It's a halo product. A halo product can attract attention to the entire brand. It can demonstrate technology. It can generate media coverage. And it can create a perception that the company is pushing the limits of engineering. And Tesla has used this strategy before. The Cybertruck wasn't designed to be the company's highest volume product, but it became a major technology and design statement. The Roadster could serve a similar purpose, but at the extreme end of performance. There are also plenty of reasons for skepticism. The next generation Roadster has been delayed for years. That alone means viewers should be careful about treating future promises as guaranteed production specifications. Tesla's current website still presents the Roadster as a vehicle available for reservation and lists its performance targets, but it does not provide the detailed SpaceX thruster specifications discussed in recent reports. So there are still unanswered questions about timing, configuration, production, and exactly which technologies will make it into customer vehicles. And that uncertainty matters, because the difference between a prototype and a production car can be enormous. So what should Tesla watchers pay attention to? First, does Tesla officially demonstrate the technology? Second, does Tesla explain exactly what the thrusters are designed to do? Third, is the technology limited to a demonstration vehicle, or does Tesla plan to offer it to customers? Fourth, what does Tesla say about safety and regulatory requirements? And finally, when does the actual production Roadster arrive? Those answers will tell us far more than any rumor. Because this story isn't really just about a fast car. It's about how far Tesla is willing to push the boundaries between automotive engineering and aerospace technology. For decades, the car industry has improved performance through better engines, motors, batteries, aerodynamics, tires, and software. Tesla is now exploring whether the boundaries can be pushed even further. But there is a difference between making something possible and making it practical. And that may ultimately determine whether the SpaceX connection becomes a revolutionary production technology or simply one of the wildest demonstrations Tesla has ever attempted. So, is Tesla really building a Roadster with SpaceX technology? The answer, at least right now, requires some caution. Recent reporting points to a possible demonstration of a limited edition Roadster using SpaceX-developed cold gas thrusters. But Tesla has not publicly released enough detailed specifications for us to treat every reported feature as confirmed production equipment. And that's exactly why this story is so fascinating. The question isn't simply whether Tesla can make a car go faster. It's whether technology from the world of rockets can be transformed into something useful, controllable, safe, and eventually practical in an automobile. If Tesla can pull that off, the Roadster could become far more than another electric supercar. It could become a technological statement about where Tesla believes the automobile is heading. But until the hardware is demonstrated and the details are confirmed, the most interesting part of the Roadster story may still be the question mark. Because the real test isn't whether Tesla can build something unbelievable. It's whether Tesla can make the unbelievable work in the real world. If you want more in-depth analysis on Tesla, EVs, AI, autonomous driving, and the technology shaping the future of transportation, subscribe to EV Insider. And now I want to hear from you. Do you think SpaceX-inspired thruster technology belongs on a Tesla Roadster, or is this better left as a technology demonstration? Drop your take in the comments. I'll see you in the next one.